This is the daily message for January 4th. Today we're going to pick up back with the idea of parameters and statistics. So if you'll recall, back before we went on break on December 24th, we introduced the idea of what a statistic is and what a parameter is. A parameter is what we would like to learn about the population, but since the population is so large and we can't inspect every element of the population, what we do is we take a sample, and from that sample we calculate a statistic. And our goal is we would like to take that statistic and hopefully learn something about the value of the parameter. So if this sounds unfamiliar, I would go back and review the material from the 24th about the difference between a statistic and a parameter, because we are going to be working a lot with those terms today. So what we're going to start looking at today is how to use that statistic to estimate a parameter. And in particular, we're going to work with one type of statistic today, and that's what we call a sample proportion, and that is denoted with the symbol p hat. So anywhere you see the symbol p hat, recall that is a statistic, and what that statistic is doing is it's looking for the percentage of something. So for example, if I was looking at cars passing on the street and I wanted to know what percentage of those cars were red, if those cars were from a sample, then that would be a sample proportion. Now, there are two ways that we're going to look at using the statistic to estimate the parameter today. They are what we call a confidence interval and a sampling distribution. You're first going to look at the confidence interval. What a confidence interval does is it says, let's take our statistic that we found and let's place it in the center of an interval. And hopefully what that interval is going to do is that interval is going to cover the true value of the parameter. So again, what we're going to do is we're going to use the statistic, construct an interval around the statistic, and hope that that interval covers the parameter. And so that's going to be the whole point of part one of today's work. The second thing we're going to look at is what is called the sampling distribution. Now hopefully you saw on December 24th, if you were to take multiple samples from the same population, and from each of those samples you calculated the statistic, the value of that statistic is going to be different from sample to sample. In other words, there's going to be some sampling variability. There's going to be some change. If you could take a whole bunch of samples from the population and from each of those samples calculate a statistic and plot all of those statistics, we would be able to visualize how the statistic is changing from sample to sample. In other words, we could visualize the sampling variability. These types of plots have a special name, and that's what we call sampling distributions. And so the whole point of the second part of today's work is going to be looking at those sampling distributions. So keep in mind, the purpose of today's work is, again, we're going to start learning how to use statistics to estimate parameters. And recall that the parameter is really what we want to learn about. It's just since populations are so big, we can't calculate the exact value of it. We have to use the statistic to estimate the parameter. So as always, if you have any questions, please use the discussion board. And also as a reminder, don't forget that tomorrow at midnight, the first Beyond the Classroom assignment is due. So if you haven't started that assignment, you do want to go ahead and start that assignment today, because part one is due tomorrow at midnight on the 5th. And then on the 6th, you're going to have exam 1 as well as the second part of Beyond the Classroom 1.